Okay, so in arid areas, surface water is almost inexistent and sporadic. So the development of life and all ecosystems depends on shallow groundwater and the surface expression of groundwater. This figure shows a west-east profile of North Chile with the Andean Cordillera on the east and the Pacific Ocean on the west. There, the hydrogeological processes are controlled by large endorheic basins. I will see if I can take the pointer. Yeah, large endorheic basins, as we can see here, with the accumulation of several hundred of meters up to 1,000 meters of detritic sediments from the erosion of the Andean Cordillera. Most of the recharge of those basins occur during the late Pleistocene and early Holocene, so large volume of groundwater have been stored, but is mainly fossil. So there is also a modern recharge. The average of precipitation is between 150 to 200 millimeters per year in the Cordillera, almost nil in the central part of the Atacama Desert that we have here, Central Depression. But here, the recharge of the aquifer is alloctone. So as in all arid areas, precipitation are much lower than evaporation, there with factor 10 as a minimum. And in the lower topographic areas, groundwater is very shallow, with less than 2 meters deep, and sometimes upwelling. So we have very specific ecosystem developed that are developing in this context. Like, for example, salt lake, wetlands, phytophytic vegetation, and trees like tamarugos, and of course also human developments with farming. So the groundwater the groundwater is a strategic resource since pre-colonial time in this area, and the different users are the population and the water supply, the mining and companies, the farmers, and the Native Americans, and of course the environment. So the water department, Chilean Water Department, monitor groundwater, realizes assessments in order to grant water rights, but the number of groundwater rights increased more than 4,000% between 2001 and 2017. So this has led to a number of problems and intensification of conflicts, and with posing the question of which management. In Chile, in the case of aquifers with a recharge much smaller than the volume stored, mainly non-renewable groundwater, the calculation of the available safe groundwater yield is equivalent to the recharge rate plus 5% of the total volume stored over a period of 50 years. So the average decline since the 90s is around 5.5 to 6 centimeters per year. That means 1 to 2 meters in 2 decades. And according to the Water Department calculations in 2010, the extracted yield exceeded 5% of the volume stored. So therefore, the aquifer was declared restricted areas, and in theory, no more permanent groundwater rights could be granted. However, the observation of the temporal data of piezometric level in the monitoring wells show a very high variability, with some place with a higher decline, almost 1.2 meters per year, but also areas where the piezometric level was stable, and other areas where the piezometric level was even increasing. So the resource is not threatened in the short and medium term because of the extraction, but knowing that so the small users have lost access to water if they were not able to deepen their well, and if they're not also able to have their groundwater right granted before the declaration of restriction, which is the case of most small users. And local ecosystems, groundwater dependent ecosystem on the other side are severely threatened, in some cases beyond the non-return point, as it has been also mentioned for a case study in China. A decrease of the groundwater level of 0.5 meter below the ground level can leave the roots of the vegetation without water uptake and lead to the wetland drying out. So while the first problem can be solved by technology, deepening wells, to solve the second issue is much more complicated. So in this case, reaching the SDG 6 and managing, implementing a sustainable groundwater management is related to being able to access the groundwater resource, but not a problem of availability of the resource, but without threatening ecosystems, which is the big challenge. And so using fossil or non-renewable groundwater, especially in the context of transboundary aquifers, can be a solution in large and heterogeneous aquifers if extraction wells are located far from the areas where the groundwater well is near the surface, with deeper groundwater, no groundwater dependent ecosystem, and on a limited period, limiting the extension of the depression cones. So two main messages: that the understanding of the groundwater system is key, and also a long-term vision for the territory development. And that's all for my presentation. Thank you very much.